Hello everyone, today we will learn how to do the experiment number E19B in the lab, that is testing of IDMTL over current and earth fault relay. I'm sure that you have learned knowledge about overcurrent and earth fault relay in your textbook, and also the theory about this experiment in the textbook. So I don't want to introduce you too much about the theory of this experiment in this video. In this video, you will see the production of this experiment in the lab and also the data collected in the lab to help you to finish the lab report. So before the experiment, I will give you some brief introduction about this experiment. What can we learn from this experiment? After this experiment, we will be able to understand the circuit arrangement of an overcurrent and earth fault relay circuit in low voltage cubicle switchboard installation. And also, we can devise methods of testing the safe and effective operation of the overcurrent and earth fault relays. And here we can see in this lab sheet, here's a brief introduction about this experiment. And the only criteria laid down in the supply rules concerning disconnection of earth faults on main circuits is that in the event of an earth fault on the system when connected TT, the main switch must disconnect in less than 5 seconds. And for large buildings, the main switch is generally a withdrawal type ABC. An earth fault disconnection is usually provided by means of residual connection of 4 protections, CTs to IDMTL type or current relays and earth fault relay. So we can see in this figure 1, this is an introduction of the connection between CTs to the IDMTL type overcurrent relays and earth fault relay. After this brief introduction, we will start the experiment. And in this experiment, it concludes 4 stages. And for the first stage, that is current transformer test. And also in this stage, we have 2 steps. The first one is to check the polarity. So in the following video, you will see how to check polarity in the lab. The aim of this step is to check the relative polarity of ZTs for different phases are the same. So firstly, we will review this procedure briefly.
We are going to do the polarity check test, and here are the current transformer, and here is the bus bar, and here is the multimeter and the DC. Okay, then contact the cables to the bus bar to form a current circuit, and then read the momentary current in the multimeter. Note the polarity. Then we exchange the cables. Read the momentary current and note the polarity, and the results should be positive to the former one.
Okay, after the step 1 polarity check, we will go furtherly for the step 2, that is a ratio check. For this step, the aim is to check that the turns ratio of current transformer matches with the value given on the nameplates. So, these are the remainder you have to keep in mind. The first one, the AC supply to the bus bar must be less than 100 amperes due to the limitation of the cable. and a number of measurements should be taken in order to get more accurate results. And third, after the ratio check of safety, all the connections should be correctly connected to the original terminals. So this is things that you have to keep in mind during the experiment to help you finish the experiment frequently. So in the following video, you will see the whole procedure of this step, and you have to, according to the data collected in this step, to finish your report.
Now we'll do the ratio check test, and this computer is to provide the alternating current, namely the AC, and the multimeter, and the current transformer, and the bus bar. This test is aimed to check that the turns ratio of the current transformer matches with the given in the nameplate. Here is the given ratio. It is 500. We can set different input current value, and now the input current is about 50 ampere, and then we press this switch to start the test. Then note the current in the multimeter is 100. To this test, we can use this equation to calculate the turn ratio, and we can repeat the test with different values of input current and obtain the average turn ratio, and finally to compare if the calculated turn ratio is matched to the given turn ratio. Here are the measurement data for the ratio check test. You can use them to calculate the measured turn ratio of the CT and to complete your lab report.
After the ratio check, we are going to do the stage 2 of this experiment. That is the secondary injection test. The aim of this stage is to make sure that the IDMT relays can work within the time limit to protect the supply system from overcurrent and earth fault. The procedure of this stage 2 is a little bit complicated, and it takes a little bit long time for the experiment. So before watching the video, you have to review the procedure briefly here. And after the procedure, you have to use the data collected in the experiment in this video to finish these results tables. So let's begin our experiment in the lab.
To do the secondary injection test, let's see the instrument first. And this is the overcurrent relay. It contains 3 phases, and the red one, the yellow one, and the blue one. And this is the earth relay. And this test set is to provide the injected current to the overcurrent relay and record the operating time. And first, make sure the output control is fully anti-clockwise, and the display reads 0. should set the value of flash bridge and the time multiplier of the relay. And look at the results table. The maximum current of relay times the flash setting is equal to the relay current. At the maximum current is 5 amperes, so 50% of flash setting equals to 2.5 amperes. And let's do the first test. The time setting is 1 and the current injected is 5 amperes. Then we should insert the bar to the exact flash setting, 2.5 amperes, and rotate the timer to the 1. Then we should set the injected current. Rotate this switch and press this button. It's to no, and then rotate it. It's near 5 amperes. Then we can start the test. Press this button, and you can see the timer is rotating. And when the relay tricks read the time, and note this data to the results tables. This is the actual operating time. Now we finish the first test. The remaining relay setting test just repeat the formal operations. First to set the values of flash setting and time setting, to insert the bar to the exact flash current, and rotate the timer to the exact value, and then rotate this button to modify the injected current. After the overcurrent relay test, we are going to do the output relay test. First, insert this device to the output relay. The output relay test is the same as the overcurrent relay test. After collect the devices, we set the values of flash setting and time setting first. Let's take the first test for example. We say the flash current is 0.5 amperes and the time setting is 1, and the injected current is 2.5 amperes. Now we just insert the bar to the corresponding slot, and then rotate the timers to the corresponding value. Then rotate this button and to modify the injected current. After all the tests, we will obtain a number of actual operating times. The next task is to compare the normal operating time and the actual operating times. So how to acquire the normal operating time? To obtain the normal operating time, we need this figure. There are several curves, and these numbers represent different time settings. And the coordinate is the multiplies of plunge certain current, namely the multiplies of relay current. And the y-coordinate is the operating time. Let's take this set for example. We say the time certain is 1, and the current ejected is 5 amperes, and the plunge relay current is 2.5 amperes. So we can use this equation to calculate the multiplies of relay current. It equals to the current injected divided by the plunge certain current. So for this set, the multiplies is 2. Now we use these numbers, this data to find the normal operating time. First, find the time certain curve. The time certain is 1, so it corresponds to this curve. Then we found the coordinate. It equals to 2 times. Then we go to the curve, find the y-coordinate is 10 seconds. So the 10 seconds is the normal operating time for the 2 times of plunge certain current. So we can note the normal operating time. It is 10 seconds. You can use the same method to find the remaining sets of normal operating times. After you find all the normal operating times, you can compare the actual operating times and the normal operating times. Then write down your conclusions from your observations. This is the results for the secondary injection test. You can use this data to complete your lab report.
Due to the time limitation, we do not have stage 3 of this experiment in our today's experiment. So we can go directly into the stage 4, that is the settings of the Earth fault relay. And also in this stage 4, the experiment procedure is a little bit complicated, and you have to use the data collected in the experiment to finish your report.
Of settings of the Earth fault relay, we also need the Earth fault relay, and then we need a stopwatch to record the tripping time. Press the right button to start recording time, and then press it to stop recording. Then read the time. Before next timekeeping, press the left button to reset. In this test, the relay current is set to 105 amperes and the time certain multiplier is 1. And make sure the bar is in the corresponding slot and the timer is set to 1. And looking at the results tables and these operating time curves, the task of the setting of the earth float relay is to measure a number of operating times on the different multipliers of relay current. And the required multipliers relay current is 2, 3, 4, 5, 6, 7, 8, 9, 10 times. And the corresponding injected current is listed above the multipliers of relay current. Because the CT the turns ratio of the CT is 500, so the primary injected current is 500 times of the actual injected current. For example, if we want to measure the operating time of the 2 times of relay current, the injected current should be 1 ampere, and the primary injected current should be 500 amperes. Parameter and the multiplier is 5 times. So if we want 500 amperes of primary current, the parameter should raise 100 amperes, and due to a system error of 50 amperes, the exact reader is 115 amperes. We should rotate this switch to modify the current. Notice now it reads 115 amperes. Now we can start this test. We should when turn on it, we should start the stopwatch at the same time. And notice the timer. When the relay chip stop the timekeeper and record the time, and then turn off it and reset. Now we can move on the next test. Now to next test, the injected current is 1.5 amperes. We just repeat the operations, and after all the tests, we have a number of operating times. Then we should transcribe the operating times to the figure, and by this we can get measured operating time curve. Then compare the measured operating time curve to the given curve And what conclusions can you draw? Here are the measurement data for the setting of the asphalt relay. You can use the data of operating times and the corresponding multiplies of relay current to draw the measured operating time curves in this diagram, and then compare this your operating time curve to the given curves, and to complete your lab report.
Okay, congratulations. You have finished all the stages of this experiment, and I hope that you can have a clear understanding of this experiment and how to do the experiment in the lab in the future. So what you have to do now is to use the data collected in the experiment and the materials, tables, sheets I shared with you to complete the lab report. And the material I would like to share with you is the data collected from the experiment. And you have to answer some questions in your lab report according to the data obtained from the experiment and finish your lab report. And in your lab report, you have to answer some questions and draw some curves. For the first question you have to answer is in the ratio check process. And in this process, you have to use this data to calculate the value of turns ratio and then compare the calculated value with that from the nameplate. And according to the calculated value and comparison, you can get some conclusions in your results and your report. And for the second question you would like to answer is that in the secondary injection test, and you have to compare the actual and the normal operating time using these results tables. And after the comparison, you can also draw some conclusions from your observations. And for the third question you would like to answer in the lab report is in the settings of early fault relay. And for this question, you have to compare the actual measured operating time with relay current curve with the given in the relay catalog. So you have to use this data collected in the setting of Earth fault relay experiment and draw your curves, and then compared with the curves in this catalog. And you have to use this catalog I will share with you later. So this is the content that you should include in your lab report in the end. And hope you can get a good grade. So if you have any questions about this experiment and the report, you can send me email. Hope you can get a good grade of this experiment, and I also hope everything goes well in the future. See you.